Okay, can we see? Yeah. I think pretty sure the next one is combinations. Okay. Sorry. Can you all see okay? Barack, sorry, do you mind just pushing this to the left a bit more? More, maybe, yeah. Okay, yeah, that's good. That's good, yeah. Okay. Okay. Combinations now. So, remember we were discussing yesterday the difference between permutation and combination. And do you remember what the difference was? The order, yeah. So, in combinations, we care or don't care about the order? Don't care about the order, okay? So, here's a very simple example to get us started. So, suppose I have a collection of 4 items and I need to choose, let's say, 2 of them. Well, how many ways could I do that? I could have AB, AC, AD, right? B, and no, I don't say BA, because I already have BA, don't I? Kinda. I have it as AB earlier, yes. So it's BC and BD, and then lastly CD. So that's 1, 2, 3, 4, 5, 6. If it was a permutation, how many would I have? How many would I have? Again, choosing 2. No? No. 12. If I was choosing 2, I'd have 4 times 3. I'd have 12. Okay? Yeah? So you can see that I have much less number of possibilities now. Of course, we can't calculate it like this. That will take a while. So we actually do have a way of calculating it. I'll scroll down now in a second. I think this is a simple enough example listing all the possibilities. And I'll give you a formula. There's a nice way of calculating here. Okay. Yeah? You got that? Got that? Can I scroll down? Yeah. So actually there's a very, very nice way for calculating this. You can do this calculation for C2. That will calculate choosing 2 from 4. So if you type in 4C2, what you get? You get 6, which is the answer we got when we listed all the possibilities. 4 choose 2 is 6. So let's have a look at some examples of using this. So our first example, you want to form a team of 2 males and 2 females from, let's say, 10 males and 12 females. Okay, so here there's actually 2 selections going on. You first choose 2 men from your 10, and then you choose 2 women from your 12. So this calculation would be 10 choose 2, and then 12 choose 2. And yeah, what's the... No, multiply.
Because it's M.
Oh.
She's alright, she's alright.
He has exactly 1 minute.
No, 2.
It just changed to 14 as he walked in.
Is it? It's still 13.
By my watch. The teacher's watch is the only one that matters in this situation. Right. Can you take out your calculator and tell me what you get here for this one? What is it? 2970. So that's a lot of possible teams you can make. And obviously you don't care about the order in the team. So team ABCD is the same team as DCBA. Yeah? Okay. Right, so that's an okay one. But let's have a look at a trickier one.
What's the front?
Yeah, write that one down. Whoops, what's that? Oh, I think you have the wrong room. Didn't that happen last week as well? Possibly the same student too.
I thought you were just rude and like, no, it's not rude
No.
for you.
Yeah. Well, I don't think is who are we still missing? Joshua and Priscilla. What's the deal with Priscilla? Do we know? Priscilla.
Priscilla is classmates.
Oh, okay. All right. Think she'll be out for the whole day, or maybe just the morning? Maybe. Okay. Right. Did you write that down?
What's the
Okay. So you can see this choose function is very nice function on the calculator. We'll do. I want to do another example, but I just need to get the numbers here. Can I scroll down now?
Yeah.
Yep. I don't know if you have this game in your home country. I'm sure some of you do. The lottery. So is it the same for everyone? You pick numbers, and then if your numbers get, okay. So let's see what it is in Arden. How many you have to pick? Oh, come on. Let's see. Nikita. Right, so
Some nostalgia going on.
you for Irish Lotto you have to choose 6 numbers. Would anyone else's be the same? Six numbers?
Yeah.
4 numbers? Yeah. Between 1 and 47. Okay, but you're choosing 4 numbers. Yeah. So here you have to choose 6 from 47. Obviously you can't choose the same number, and obviously the order doesn't matter. Okay? So using your calculator, tell me how many possible different lotto tickets there are. Should be pretty big. 47. Choose 6. Oh yeah, okay. That's. Is it 10 million? 10.7 million. Yeah. So, what does that make your chance of winning if you buy 1 ticket? 1 in 10.7 million. So, don't expect to win. Yeah?
You want to it.
Yeah, pretty sure you won't with 1 in 10.7 million chance. I think just before I do the next example, the thing that always confuses people, suppose you make this choice for your 7 numbers: 1, 2, 3, 4, 5, 6, 7. Is that a good or a bad choice for lotto numbers? No, it doesn't matter.
Yeah.
All outcomes are equally likely.
Same, yeah.
You're just as likely to get these 7 numbers as any 7 numbers. It doesn't matter. In fact, this is a better list of 7 numbers to pick, because it's unlikely someone else would pick this. So in the unlikely event you do win, you won't probably share the prize with someone else, because who would pick these 7 numbers? It seems too unbelievable that these 7 numbers would come up, but they're just as likely as any other 7. So actually this is a better choice to pick than any other choice. Okay, let's do another example here. Okay, let's see. I'll give you a small one to try. So we'll go back to our deck of cards. And you draw 5 cards. And this is an example we said yesterday of where it doesn't matter the order that you get the 5 cards. And I want to know, you can see where this is going, how many different hands can you be dealt here? It's 52 in a deck, yeah. 2.5 million, isn't it? 2.6 million? 52 choose 5 is 2.6 million? Almost 2.6 million. Yeah. Okay. Now, we'll start looking at a harder one now. We'll go back to the lotto example. So, let's just get lotto. Okay. Right. Can I scroll down? Yeah. Okay. So we'll go back. I'll just remind. Oh, what did I say? 47 numbers, wasn't it? And then you choose 7, wasn't it? Oh, was it 6? Yeah. Choose 6 numbers. And let's see. Yeah, I can see there's a prize here of €11 if you match 3 numbers. If you don't get all 6, if you match 3 of them. Okay, so I want you to calculate how likely that is. Now I'll give you a little bit of a hint here, okay? We know the formula for probability. It's the total number of outcomes that we want divided by the maximum number of outcomes. Now we already know that. For the lotto game, how many different outcomes are there? Yeah, it was 10.7 million, wasn't it? So 10.7 times 10 to the 6. So you've got to figure out on the top, how many ways can you match 3? So actually don't worry about the probability just yet. Just tell me how many ways you can match 3. And it's not 47 choose 3. No, more than 6.
9.
I know, you could just think about it and write something down. Yeah. You pick your 6 numbers as normal, and 3 of them match the winning numbers. Well, how do we calculate it? Let's see. So, no. No. So this one's a little bit harder. Let's think about it like this. You have your 47 numbers, and 6 of them turn out to be winning numbers, right? And then 41 turn out to be losing numbers. Now, you almost had it with the 6 choose 3, but not quite. You want to choose 3 numbers from the 6 that are winning numbers. But you want to make sure that the other 3 numbers are losing numbers. This way you have exactly 3 that win. So in a way, you're choosing 3 numbers from 6 and also 3 numbers from 41. So it's not just 6 choose 3, it's 6 choose 3 times 41 choose 3. And this is a lot like the first example I did with the selecting the men and the women. Okay, so you're choosing 3 from the winning 6 and choosing 3 from the losing 41. Yeah? So what is that number? 200,000? Okay.
Not exactly, but
Well, roughly. Okay. So then what would be the probability to match 3? That would be 200,000 roughly over, what do we say, 11.7? Wasn't it? 10.7 million? So what's that? 1 in 53 roughly, is it? Roughly 1 in 53? About 2%? Yeah, 0.0199. So we'll say roughly 2% then. That doesn't seem as bad compared to 10.7 million. You have a 2% chance of winning 11 euros.
How much is it? Tickets?
I think tickets are 2 euros.
I don't have this one.
The next prize up here for 61 euros is if you match 4 numbers. Right, let's see, how many ways can you do that now? Calculate that, matching 4. No, just a number. How many have you got? Huh? 12,300?
Yep.
Yeah? Yeah, okay. And then, next one up, for 2,000 euros, if you match 5.
4,000?
2,000 euros,
Oh.
if you match 5. So, how many possibilities are there for that? So matching 5, yeah, what would that be? That would be 6 choose 5 times 41
Is it
choose
oh, yeah.
1. Yeah. How many is that? 246.
Yes.
Why choose 1?
You want one of your 6 numbers to be a losing number and 5 of them to be winning numbers.
Yes.
Oh, okay. Can I make can I do the opposite for 2 and 5 and 6, 1?
No, it has to be this way. You're choosing 5 from the winning 6 and 1 from the losing 41. Okay. I'm going to give you a little question now. I'm looking at the website here and it's telling me how many people won this prize. 15 people won this prize. So actually from that piece of information I just gave you, you can tell me how many lottery tickets were sold.
15 only?
Only 15 winners of this prize, of this one. 15 won, did I say this prize was? About 2,000 euros. This is by matching 5 numbers.
Wow.
So you can actually tell me how, if you think about this, you can actually tell me how many people played the lottery that night.
Full divide, yeah.
I won't tell you. Let's see what you can come up with. Yeah. How many? That's not enough people. Huh?
No, divide by probability.
Yeah, that's getting. No, more people play. If only 6,000 tickets were sold at €2 a ticket, how could you have a jackpot of millions?
$30,000.
Again, these are all numbers
Half of
way
a
too.
million?
Still probably too small. Although maybe I'll have to think about it. So look, okay, guys, okay, you're not getting the logic here for this one. How many possible lottery tickets are there? We said earlier. 10.7 million. Okay,
Yeah.
10.7 million. So let's suppose 10.7 million people played and they bought 10.7 million tickets, right? So everybody has bought at least one of the combinations, right? There'd only be one big jackpot winner. How many people would win though the match 5 prize? 246. Okay? If everyone bought every combination, you'd expect 246 of those tickets to be the match 5 winners. However, there was only 15. So you can do it as just a proportion. You can just do 15 over 246 times 10.7 million. Let's think about it like this. Suppose we were expecting 246 winning tickets from 10.7 million and we got 123 winners. That's only half the number we expected, so there must have only have been half the players. It's a proportion thing. Yeah, what is this?
650
1,000?
Yeah, approximately.
Yeah,
Like
roughly
8,000, yeah.
this many players.
But I just forgot the total number.
Okay.
10.7.
Can you repeat?
I can, but this is like, you understand that this isn't really maths, this is just logic. Brain logic, yeah. Okay. Let me do another example. So, oh, you want to write it down first? Okay. Nikita. Okay, so look, let's say you're running a competition and you have 100 tickets you can sell and they're numbered 1 to 100, and then you pick a number and whoever has that number wins the prize. Okay, so you sell all the 100 tickets and okay, let me actually change it a little bit. Let's say you don't pick just one number, let's say you pick 10 numbers. Okay, so you pick 10 numbers, there's 10 winners. You sell 100 tickets, you pick 10 numbers and 10 people win. That's fine, okay. Now let's say you don't sell all the 100 tickets. Let's say you only sell 50 of the tickets. And you pick, again, 10 numbers. Will 10 people win? No, because you could be picking numbers that nobody bought. In fact, how many people would win in that situation?
50.
5. Half
yes.
the prizes.
No.
Okay. The proportion, that's it, it's the proportion. That's what's happening here. If every possible ticket was sold, then you would expect 246 winners. But you didn't get 246 winners, you only got 15 winners. That must mean not every ticket was sold, obviously. The proportion again is what tells you how many were sold. Like if you look at this, this is, I don't know, this is about like 8% of this number. So that means that only 8% of the potential tickets were sold? Because you only had 8% of the potential winners. It's just a proportional thing. Yeah? Is that okay? Yeah, but yeah. None of you got it though. Right, let's see. I was going to do poker hands, but considering how difficult that one was, no, I don't know.
No, we should try.
I don't know. I'm trying to pick the easiest hand, perhaps. Hang on. Let's see. Oh, okay. I'll let you try it. I'll give you one example. We'll see if anyone gets it. I'll give you a minute to try it. So we did the calculation earlier. What was it? 52 choose 5. What was that? 2 million or something, wasn't it? Yeah. That's how many different hands you can be dealt. Okay. I'm looking for how many of those hands will be 4 of a kind. And 4 of a kind, for those of you who, well, I'm sure at least one person in this room knows what 4 of a kind is.
Yeah.
What is it?
It's like 4 A's, 4 Q's.
Yeah, 4 the same.
Yeah.
Yeah. And then you don't care what the 5th card is. Yeah? You understand? It's like, for example, getting 4 kings.
Yeah.
Or something like this. Or 4 aces. Yeah? Yeah?
Yeah.
Okay, okay. I'll give you a couple of minutes, see if you can work this out. Now think, it's not easy, think carefully about it.
It could be 4 twos. Anyway,
Yep. Yep. You got it? A little small. A little small. A little big. Any other answers?
No.
Now, I'll give you a little hint. Another way to think about it is what choices you're making. So, for example, the first choice you're making is which card you're going to have 4 of. So, maybe it's 4 kings or 4 queens or 4 aces or whatever. So, how many choices are there to be made?
13.
13 choose 1.
Yeah.
Yeah.
I choose
Only
one.
4 kings.
Yeah?
Definitely.
Why choose one?
That's hard time.
Alright, let's go
Hard
first.
time. Really tough. Only 4. Yeah.
Maybe
All right, let's have a look. Let's have a look. Let's have a look. We'll look. So, we don't care about the order, right? So we might as well put the 4 cards we want at the front. 1, 2, 3, 4, and then we have our 5th card here. Okay. So these 4 here, and then this one is free, so to speak, or well, not free. We'll leave it for the moment. Okay. So if we look at these 4, we could have 4 aces, or 4 kings, or 4 queens, or whatever. We have a choice of 13, and we're choosing one of those 13. It's like saying, what do you want your 4 of a kind to be? Do you want it to be 4 aces? Do you want it to be 4 kings? Do you want it to be 4 queens? How many choices do you have there to make? 1 from a pool of 13.
why one?
What?
Yeah,
Because
why
only
one
4
and why
cards
13?
can be fitted in 4 boxes.
Yeah.
How about same symbol?
I don't
For
understand
that,
No, that's not 4 of a kind.
but it's
No, that's not 4 of a kind. 4 of a kind is the 4 same cards.
okay. Same number.
Yeah.
Yeah.
Oh, so they're including the numbers as well.
Why 13?
Hang on. Do we need to go back to what's 4 of a kind? Yeah. It's okay? 4 of a kind is 4 of the same card. Like 4 kings, 4 queens, 4 aces, 4 sixes, 4 tens.
Yeah.
4 the same.
Yeah.
How many possibilities are there to choose? 13.
Yeah.
You could choose an ace, a 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, king, queen. You can have-
52 divided by
Yeah,
4.
13 choose 1 is the first one. Yes?
Ugh, I don't understand.
Yes?
Yeah.
So that's 13 choose 1. Right, so let's calculate, what's that? That's 13, isn't it? Fine, okay. Now, this last one here, so after these 4 cards have been dealt, so you went 1, 2, 3, 4, how many possible cards do you have left here that this could be?
40.
48. Isn't it? Yeah, 52 minus 4, 48. Is there any restriction on the last card?
No.
None whatsoever. All 48 are perfectly fine to get.
TC1 times 48.
And that's all.
That's all. 624. So there's 624 4 of a kind hands. I told you this one was hard.
Probably if you could like illustrate it from this chart to like get
Draw
to
some
the mind.
pictures.
Yeah.
Okay. I picked that hand because it was the easiest one. You won't get any of the other ones. They're much harder. No, I know you won't. Let's see. Yeah, that was the easiest one for sure.
The easiest.
For the poker hands, yeah. Anyways, you can see that it's unlikely to get that because what do we say it was? Something like 2 million? So you have 624 over 2 million. So it's not likely that you'll get this hand. There's only 2 more hands that are higher than this. So the next one up is straight flush, and there's 36 possibilities to get that. And then the highest hand is royal flush, and there's only 4 possibilities to get that. You can actually just list the 4 out. It's ace, king, queen, jack, and 10. But of the 4 different suits. So you can have ace, king, queen, jack, 10 of spades, ace, king, queen, jack, 10 of diamonds, ace, king, queen, jack, 10 of hearts, and ace, king, queen, jack, 10 of whatever the last one was. I didn't say. Clubs, yeah, okay. So there's only 4. So what's your chance of getting the highest hand? 4 in 2 million. Yeah. Not likely, huh? 1 in 500,000. Yeah. Okay, so let's try these for a few minutes. Let's see. Again, 1 to 6 is fine for this.
1 to 6.
1 to 6.